Ooh. Bet you didn't expect it that time. I covered. Anyway, hey everyone, I'm Ryan. Welcome to day 6 of Advent of Code. We've been doing these past 5 days. Every day there's a new puzzle. About 5 minutes ago, a new one just came out. That's day 6. So for those of you who haven't seen the other videos in the series, Advent of Code, every day we get kind of like 2 puzzles, um, and we solve them in Elm. So I'm using Ellie. Ellie's like the code pen for Elm, and I'm able to like make changes in the browser, get the answer, and also get all of Elm's really nice compiler errors right here so that I can figure out which typo I made. But yeah, so that is pretty much it. All this program is doing is just printing out some text, and I have it set up so that I can print out any type of thing. So as we kind of do things step by step, we'll be able to see it. And hopefully me talking through my thought process will help you if you're new to Elm, or if you're not new to Elm, but you just like to hang out. Anyway, let's dive in and let's see what's going on for day 6. All right, the preparations are finally complete. Oh yeah, our elves are going through a jungle or something. It's a crazy story every day, so we're gonna see what's going on. Preparations are finally complete. You and the elves leave camp on foot and begin to make your way toward the Star Fruit Grove. As you move through the dense undergrowth, one of the elves gives you a handheld device. He says that it has many fancy features, but the most important one to set up right now is the communication system. However, because he's heard you've had significant experience, what is this? Day 6? Oh, this is like other puzzles. Significant experience dealing with signal-based systems, he's convinced the other elves that it would be okay to give you their one malfunctioning device. Surely you'll have no problem fixing it. As if inspired by comedic timing, the device emits a few colorful sparks. To be able to communicate with the elves, the device needs to lock onto their signal. The signal is a series of seemingly random characters that the device receives one at a time. To fix the communication system, you need to add a subroutine to the device that detects a start of packet marker in the data stream. In the protocol being used by the elves, the start of a packet is indicated by a sequence of 4 characters that are all different. The device will send your subroutine a data stream buffer. Your puzzle input. Your subroutine needs to identify the first position where the 4 most recently received characters were all different. Specifically, it needs to report the number of characters from the beginning of the buffer to the end of the buffer, or end of the first such 4-character marker. For example, suppose you receive the following data stream buffer. So MJQJP, whatever. After the first 3 characters, MJQ, have been received, there haven't been enough characters yet to find the marker. First time a marker could occur is after the 4th character is received, making the most recent 4 characters MJQJ. Because J is repeated, this isn't a marker. So J shows up twice, so that doesn't count. The first time a marker appears is after the 7th character arrives. Once it does, the last 4 characters received are J, P, Q, M, which are all different. In this case, your subroutine should report the value 7 because the first start of packet marker is complete after 7 characters have been processed. Okay. So let's take a look at this. So it's saying after the 7th character arrives, 1, 2, 3, 4, 5, 6. So I'm just kind of looking for like things that are 4 different. So no. QJPQ, no. JQPM. I think, yeah, this is it. PM. GBL. Okay, so that's the 7. And then J hits, and that's what resets it. Okay. Here are a few more examples. Okay, so we've got a bunch of examples here, and we expect, for all these examples, we expect 5, 6, 10, and 11. So what I'm going to do is I'm going to take this input, and we're going to try to do the puzzle together, and we're going to just see if we can get 7 to be spit out here. So we're just going to do this one step at a time, and let's dive into it. So starting with just printing out the string. This is the string we have. What we need to do is we need to loop through each character and kind of keep track of like how many characters max we found for the given thing. So trying to think of an efficient way to do it. I think that think we just need something called find longest marker. So find longest marker is going to be a function that takes in, our input string, and it's going to return maybe the longest string it finds. So hopefully, if we do our puzzle right, it's going to return. Is it find the first? Buffer than the first such. Okay, so it's going to find the first. I think it's just the first marker. Let me just validate that that's what it is. So first marker after character 5. So B, V, B, you got B, J, P, L. First marker after character 5. I think this is. I would have thought this was the first marker. Maybe I don't understand this. There haven't been enough characters received yet. The first time a marker could occur is after the 4th character is received, making the most recent 4 characters MJ. Because J is repeated, it isn't a marker. First time marker appears is after the 7th character arrives. After the 7th character arrives. 1, 2, 3, 4, 5, 6, 7. It's saying after. You need to process for this first start of. What was the bit about? Oh, maybe I misunderstood. First such 4 character marker. I just need to report when I get to 4, I think, is all. Maybe I overcomplicated it. Okay, so it looks like the first time I see 4 unique, if I basically just like look at these, look at these, look at these, I keep doing that until I get to here. And when I get to here, I report 7 because it took me 7 characters to get there. So I look at these, there's a repeat. I look at these, there's a repeat. Oh no, I look at these, there's no repeat. So I report 5 because it took me 5 characters to get this. Okay, I think I get it now. Repeat, repeat, unique 4. Okay, cool. We can do this. So, first marker. So I don't know if we want maybe string here. This will be our string. What we're gonna do is we're gonna grab start at index 0. And what we're gonna do is we're gonna say string dot take. I guess we're gonna drop. Oh, we can do slice. String dot slice. We're gonna start at the index. We're gonna go to the index plus 4. And then we're gonna give it our string, and hopefully this is just gonna print out these first 4 characters. Okay, great. So all we're gonna do is we're gonna say first 4 characters. So we're gonna do this. That's what we're returning. So first 4 characters, what I want to do is I want to turn this to a list. String dot to list. This will give me a list of characters. And then what I can do is I can use this set data structure. So what the set does is it gets rid of duplicates. So set, I'm just going to expose set in case I need it. So now I've got this set coming through. And so notice that because the set removes duplicates, the length of the set is less than 4. So that this length is 3. So length of characters, I guess. So this will be like how many unique characters. So copy this. This is going to be an int. So I'm going to say if, oh, how many is kind of weird. We're going to say unique character count. unique character count. Class rename, I promise. And then if unique character count is greater than or equal, or I guess if it equals 4, then I found the index I want. So I want to return that last index. Otherwise, I think I just want to drop the first element from the string and then pass that into find first marker. Or I can pass in the string as is. And I just need to update the index that I'm looking at. So find first marker. I'll add 1 to the index. String. So I end up with 7, which is the puzzle answer. Okay, let's format this a little bit. So yes. So in this case, I'm also going to print out, just for debugging, so we can see that we're getting the right thing. We are going to marker is going to be a string. All I want to do is just print out the marker here. So this is a way that we can do this, and then in the logs we'll see what marker we found. So we can try this with other items. So hopefully we get VWBJ here. Let me zoom in a little bit. Hopefully that's readable enough, but cool. So we get that, and then I think our answer is 5. Awesome. So this one says 11. Let's try that one. 11, and then ZQFR is what it found is the first non-repeated thing. So how many characters need to be processed before the first start of packet marker is detected? I think that's part 1. So what I'm going to do is I'm going to take this input, I'm going to put this back, I'm going to save this, and then I'm just going to run this so that we have our answer. And so for all these videos, I just kind of save these, put them in my little notepads so that I remember to put them under the day 6 video links. So in the description, all this code will be available and you can run it yourself. But what I'm going to do is I'm going to get my unique puzzle input. If you sign in with admin code, you're going to get a different string than me, so your answer is going to be different. But let's take a look and see what we get. 1655. Awesome. Okay, we got a gold star. That was a lot easier than yesterday. Let's see what part 2 does. So usually part 2 is going to be like a slightly more challenging version where we see how easy it is to refactor our code. Let's see how it goes. All right, your device's communication system is correctly detecting packets, but still isn't working. It looks like it also needs to look for messages. The start of message marker is just like a start of packet marker, except it consists of 14 distinct characters rather than 4. Here are the first positions of start of message markers for all of the above examples. So 14. So I think it's the same thing. We just, instead of doing 4, we do 14. So we can test this out. We can use that same input string. And we're getting 7. And it says 19 is the answer if we're looking for 14 distinct characters. So I think that's it. I think that's all we had to do. So this variable kind of represents like how many characters we're looking for. Find first marker is probably not a great name, and I should probably also add an annotation for you. But this is going to give us the think there's also this can just go on infinitely if it never finds one, but you know, that's life. Cool. So I think that's right. I think that's literally it for day 2, or for part 2. So let me save this. I'll take my puzzle input. Sorry, let me copy this link before I forget. It's that. And we're going to copy our puzzle input. And we're going to paste it here. Get 19. That's not right. Hold on. Compile. There we go. 2665. All right. Well, that was day 6. Thanks for hanging out, everyone. We're making good progress. Let's check out the calendar. Yeah. So in 24 hours, day 7 will be available, and I'm totally down to record that video. Yeah, if you want to learn any more about Elm, like we use this set data structure. This is probably one of the easier Advent of Code challenges, and all we really use is set. Everything in Elm, everything that the core library supports, is all available here. So in the description, there'll be the solution for part 1, solution for part 2, and then there'll also be a link to these package docs, Advent of Code, as well as the Elm guide if you want to learn. But I'll see you tomorrow. Thanks for hanging out. And yeah, happy December.